Thank you guys for joining me for another shop experiment. We're gonna test this vise out, hopefully break it and see how much it clamps. This is my answer to having a vise on one of these fixture tables. I like having a vise as close to whatever I'm working on as possible. And if I'm on this table, I want a vise right here. That means I'm not running around the shop. This is just a 4-inch small vise we sell on the website, but we made some changes to it to make it more universal for somebody that has a fixture table like this. Most of the vices you purchase don't have a proper square bolt pattern, where these bolt pattern that the vise has on the base is on a 2-inch grid. So you can remove it, position it anywhere you want with relatively ease. I know that's one of the benefits to having a fixture table, is just you want to be able to move stuff around. So because of the bolt pattern, I can put it anywhere I want to clamp and hold, doing whatever I want to do. I like it because it's also light. I don't want some big gigantic, big heavy thing that I got to be moving around all the time. So this 4-inch vise is just perfect for that. That's why you guys see me use it on the end of my table all the time. If you have a Build Pro table, you can use the ball lock bolts, or any others, you can just use a 5/8 bolt and bolt it straight down to your table. I'll show you the vise measures 4 inches across the jaws, and then it'll open up to 6 inches, which is actually pretty good for this little vise. The other neat thing too is that it has these adjustment screws right here on the way of the slide, so that you can adjust how much slop there is if it ever does get wear in it. So I like that too. And now that we got the vise open, I want to put this meter in here and clamp to see how much force this little guy can produce. But I don't want to wreck my meter, so we also sell these copper soft jaws that I'll plop in here real fast, and that way we won't wreck the meter. So let's do that real quick. Okay, we got the soft jaws all installed. Let's put the squeeze on this baby. Oh man, what'd I get to? Wow, 2,165 kilograms. That's pretty spectacular. What's 2,155 kilograms to pounds?
It's 4,750.96 pounds.
Whoa, 4,750.96 pounds. That's a lot. That's 2.5 tons. That's pretty crazy. It's a lot of force for this little guy. This is what I'm talking about. Where's my safety glasses? Here. Face shield on. Much better. Ready? Woo! Okay, that's all the handle can take. 4,455 kilograms. What's that in the pounds?
That would be 9,795.14 pounds.
Look at look at it bowing. It's still holding together. Let me cut this handle off and let me make something that's a little more suited for this project. So let's do that. Okay, round 2. We got a little attachment on here. We got it through bolted with this big piece of bar on here. So we are gonna break this baby, I have no doubt. Let's see what this baby can do. Let's see if I get out of the way. Well, look at it bend. Oh, something's gave. I heard it. Oh, I heard it right there. We got a failure. Let's just keep going and see if we can break it off. There she goes. I broke the thread right off that baby. Pretty crazy. Check this out. The collar seems pretty good. The rod even seems pretty straight, besides that it's missing the other side of it. The slide, we got her a pretty good bow, but really the weld held up pretty good. I'm pretty surprised. But realistically, I mean, this exceeded way beyond its design limitations. You should not be exerting any more force on it than this length. So that's the #1 rule of vices, is don't put cheater bars on them. That's how you end up breaking them. Even though this device wasn't designed to do what I just did, I'm actually pleasantly surprised to see how well it performed in this destruction test. So if you guys are interested in this little baby vise here, I'll have a link in the description below, and I'll catch you guys on the next one.